Hey, you okay? What's up? You okay? Guess not. Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in this week's video we're going to be making some flanges out of a piece of 3/8 inch thick aluminum. These flanges will be used as part of an electric motor installation on an offshore fishing boat. Uh, I've actually made those flanges already. These are for a friend of mine. I made them. He's picked them up, and I'm pretty sure they've been installed by now. The boat may already be in the water as far as I know. But the video of making those flanges for him was just not usable. So we're going to make another one today because there was, I think, a lot of interesting steps in making these flanges that would make a good video. Here's what his finished product looked like. These are 2¼ inch across diameter, and he told me when we were discussing this that there was only two critical dimensions on this whole project. One was the diameter of this hole. He wanted it to be exactly 15 millimeter, and the other was the depth of this insert. He's got a piece of gasket material that's a little over 2 millimeters thick. So he didn't want this indention that we mill out in here or machine out, didn't want it over 2 millimeters. As a matter of fact, he specified get that as close to 2 millimeters as possible. Now, to make another one of these, he may have a use for it someday. If he does, I'll have it in the inventory. But all it's going to take is a piece of 3/8 inch material. So let's go over to the workbench and get it laid out. Let's locate the center. All right, we set our overall diameter for the piece was 2¼ inches. So the way I like to lay out something like this, everybody has their own methods, I'm sure. But half of 2¼ is 1.125. I like to get that dimension on my calipers and then come over to a piece of paper and simply put a little indentions. That makes it much easier to set the dividers. We'll actually be measuring this, of course, on the lathe as we turn it, but this will give us a mark to shoot for. Like I say, that'll be a mark just to shoot for. Now, we want to go ahead at the same time too and lay out this. That will be 1/8 of an inch. So we want we'll lay out a 1 inch hole on the piece of paper again and set the dividers to that. And these are just guidance marks. I'm going to quickly do the same thing on the back side. All right, I got this laid out, and we're going to turn, again, just like I did in a video a couple weeks ago, we're going to turn the square piece into a round piece. But in that video, several of you pointed out that I could have saved on some of the turning on the lathe if I'd gone over to the bandsaw first and cut off the corners, and you're correct. But in that case, the piece of material was square, the same dimension as the desired round. So there wouldn't have been a whole lot to cut off, plus it was kind of thick material. But in this case, there's right much to take off. This is a piece of 3 inch, and we're only wanting 2¼ So we're going to run over to the bandsaw right quick and cut these corners off and get it down close to size. Now, don't leave me. As I said in the video where we made these, where we turned the square pieces into round, we use one method of doing that on the mill, or on the lathe. We're going to use a little different method this time. Workpiece that got a little hot, I had to cool it off a bit. Okay, that took a few minutes to get that whittled down closer to size, but all these pieces here are pieces that won't wind up as chips in the lathe and have to be cleaned up. Now remember we said that this hole in the center here was only one of two precision measurements required on this piece. Right now we're going to drill this with a 1/2 inch, and you'll see why in just a moment. And I'm just using a couple parallels on my V-block here just to mount this down in the mill vise. Be sure I get it seated down good on the parallel. Now we'll use this little pointer. We'll use it just to find that witness mark we punched in there at the workbench. Alright, now let's turn over to the workbench and talk about how we're going to hold this workpiece different than the way we did a couple videos back to turn it into a round piece. Okay, in the video from a couple weeks ago, if you recall, I just used this shop-made mandrel. This held in the lathe chuck with our two workpieces wedged in here, and we kept turning it until it was round. In today's project, we're going to use what's called an expanding mandrel. These have a taper on this end and an internal matching taper on the other part. And this is a number 1, and a number 1 goes from 1/2 inch to 9/16. As this goes further on, it spreads out, but the two matching tapers keeps it parallel. So we'll put our workpiece on here, and pretty much all you've got to do is just get it started and give it a good tap, and that's pretty much locked on there. Now the way we hold this, in the chuck we'll have another just center. This is something turned that I turned here in the shop. Just keep in mind each time you use this in a 3-jaw chuck, you need to dress up this taper. On the other end, in the tailstock, will be the live center, of course. This will be turned, this workpiece will be held between centers. It'll be the live center on one end, and this in the chuck and the other end. And this will be driven by what's called a lathe dog. So let me get that set up on the lathe, and you'll see how it all works. Now remember I said that anytime you use a center in the chuck like this, you need to redress it. So I'm going to set it up in the chuck. I've got my compound slid all the way back on the cross slide, and I've got the lathe in reverse. And it's just easier to run the compound like this than take a chance running it over here. The workpiece would have to be sticking out, which would counteract the redressing of it. So I've got the lathe in reverse, and all I want to do is just clean this up. We know a 3-jaw chuck has, all of them have a little bit of run out. All right, I'm cutting all the way around now, so that will be good. All right, I'm going to get the compound set back in the correct direction and bring you back when we get ready to mount this between centers. All right, the expanding mandrel has a flat side on it. We're going to use the lathe dog. Now this will go, it'll be driven by one of the jaws on the chuck. Tailstock up. The nice thing about turning between centers, as we're set up here to do, is that if you need to take the workpiece out, go over, measure it against something else, you can do that by simply backing off the tailstock, take the workpiece out, come back and put it back in, and as long as you don't move the center that we just trued up, and you don't take the workpiece off the mandrel, you shouldn't have any issues at all with taking it off and putting it back on. All right, I'm just getting the everything set up to where I got clearance. All right, I think now we're ready to start cutting. And again, I've got witness mark on there to the 3.5 inch, which is going to be pretty close to where it clears the first time, or cleans up all the way around the first time. So we'll find the high spot. The lathe is backing forward. All right, let's just come up to where we just touching. And unlike the shop-made mandrel where we had the nut on there that we could tighten it down, extremely tight, this we won't take quite as big a cuts on because it can turn on that mandrel. Alright, it's obvious I don't have it tight enough on that mandrel. So like I say, we can take the workpiece out. And I'm going to carry this over to the vise and just tap that down a little tighter. Alright, I've got that a little tighter on the mandrel now. And I hope this works because I like using these expanding mandrels. I made the other two this way. For some reason this one wants to slip a little bit on me. I think I may have some extra sharp corners on this that I need to, that once I get them cleaned up, it'll hold a little better. Alright, we're getting close to our witness marks now. Let's give this a measurement and see how close we are to the 2 1/4. Remember, this is not a critical measurement at all here. It looks like just about 6 more thousandths. And that should be just enough to clean it up maybe. Or not clean it up, but put a nice finish on there. 2.251. I think 1/1000th is good enough. Now we're going to put that rollover on, and to use that I've got just a piece of high-speed steel ground with a radius. And we're going to turn our RPM down considerably for this. I also need to get the tool a little better aligned with the workpiece. Alright, that's got a good round over there. We'll put our turning tool back on, come around to this other side and just clean that up a little bit. We don't want much of a chamfer on this. That's the surface that'll be up against the body of the boat that the wire will go through. Alright, I'm going to take this off the mandrel now, and we're going to turn it around and get set up to bore out this recess and also get it cut to size. Okay, to hold our workpiece in the lathe turned around where we can get to what we'll call the bottom side, I'm going to use a spider again. And you've seen me use this in previous videos, and as I've said before, this is probably, of all the jigs and templates and mandrels and various tools that I've made, fixtures that I've made here in the 10-born, this one gets used more than any other single one. I have different height spacers to go on the back of it. These are 1/4 inch, I got some 3/8, and I've also got some 1/2 inch. But that will set up tight against the chuck. Then we can mount the piece in like such. Snugging it up good. And I always take my soft blow hammer and just be sure it's seated up against the chuck. Now I want to talk some numbers right quick with you. You remember this hole in here needs to be 15 millimeter. That was one of the two critical measurements on here. We drilled this out to a 1/2 inch while ago. A 15 millimeter, well, we drilled it out to a 1/2 inch a little bit ago. In the imperial world, when we're reaming, let's say we're reaming a 1/2 inch hole, we would drill it a 1/64 less than the reamer size, which would be what, 31/64. I had no idea when I started making these before about metric reamers. We're going to run a 15 millimeter reamer through this after we get it drilled to the proper size. Now, as I said, in the imperial world, a 1/64, you would drill 1/64 less than your desired ream size. I got on the web and looked around, and the best documentation I could find said when you're reaming for a metric size, to drill it 0.4 millimeters smaller than your desired ream size. Now, I did a little bit of conversion. A 1/64 is 0.0156. 0.4 millimeter is 0.0157. So basically, you're expecting your metric reamers to cut 15.7 thousandths, or 0.0157. Now, a 14.6, which would be the 15 minus 0.4, is a 575 in imperial size. I don't have a 14.6 millimeter bit nor a 0.575, but I do have a 9/16, which is 0.563. And that means the reamer is going to have to cut about 6 thousandths more on each side. But I think in this aluminum that will be fine. I would be curious to know from those of you that do a lot of metric work, how you size down. Do you go 1/2 millimeter or try to stick with the 0.4? In any case, we're going to drill this with a 9/16 imperial bit, and then see if that 15 millimeter won't ream it out like as desired. Get my tailstock moving again. Okay. All right, now let's put the 15 millimeter reamer in. And this is the chucking reamer versus a hand reamer. So there's our 15 millimeter desired dimension for that hole. Now we're going to want to remember we're going to cut out up to this witness mark here no more than 2 millimeters deep. And for that I'm going to use a smaller boring bar, 3/8 boring bar. And I'm going to just touch the work material with the tip of the boring bar and zero that out. Now double check right quick with the interwebs, but 2 millimeter is 0.0787, so 0.079, 79 thousandths. We don't want to go any deeper than 79 thousandths. So I've got the z-axis zeroed out. I'm going to come in half that right now, 40 thousandths. All right, hopefully you can see what I did there. Now, I'm not going to come the full 79 thousandths. I'm going to stop at about 70 thousandths. And we'll get a measurement then. And I just came out to that, about to that witness mark that that you saw me put in there at the beginning. Now we're going to measure across that, but before we do that, we need to clean it up just a little bit. I'm just going to take this deburring tool and clean this edge right here just very carefully. Now we'll take our depth micrometer. 75 and 15 is, let me be sure I got that. Looks like I got it 10 thousandths too deep. All right. Yeah, I turned you off for just a minute, but I got to looking, and I had a bit of a chip still right where this was sitting. Okay, measuring it after I went back and cleaned that up a little bit more, I'm at 75 plus 3 is 78 thousandths. So I'm within a thousandths of what he requested there. All right, I think the only thing left to do to this, or let me make one comment here. If I had got that too deep, it wouldn't be the end of the world. Remember, the thickness of this is not critical. I could have simply pulled this workpiece out a little bit, put a spacer behind it, so I could get to this outside edge and trim just a little bit of that outside surface off, again, so that that was no more than 2 millimeters deep. Okay, I guess I forgot to turn the microphone on in that last little segment. But what I did after finding the center, I drilled and counterbored for four number 8 screws. The original pieces that I made for my friend had 1/4 inch holes through there. But in hindsight, I believe he would have been just as well off with smaller screws and might have looked a little bit better. But I hope you've enjoyed this little video of making this flange. Take care, and I'll see you on the next one.